Hello, I'm Robert Yule, and this is the 11th in my series on being a good steward of God's kingdom, as God commanded us in Genesis 1:26. Today, we're going to be talking about the cheapest way to save energy. But before we get to that topic, I'd like to review what we covered last week and give you an example of that. So last week we talked about it's about the motors, and then things that get hot, and then maybe the lights. That's the best order to look for savings because motors use by far the most electrical energy in an office or a factory or even in a home. And so I'm going to give you an example of a project I worked on where we started with motors. The reason that this is easy to do is that the energy used of a motor is proportional to the square of the speed of the motor. And most times, people without thinking run the motors much faster than they need to run, and that uses a lot of energy. If we slow the motors down, then we can save that energy and we still get the desired cooling, heating, fluid flow, airflow, whatever it is that we're trying to obtain. So in this particular project, we were building a brand new factory. We didn't have time to start the building from scratch, so we had to find an existing building. And the only building that had enough ceiling clearance for the equipment we were going to put into it was a large warehouse building. And it, in fact, was quite a bit larger than we needed. And this gave me an opportunity to do something well that we normally don't have, which is I could slow down the fans that move the air in the building. And this was in a very hot climate, and we needed to move a lot of air and do a lot of cooling. And so this was something that was a concern to me long term in terms of our costs. The way I did that was when we built the factory, I directed the design team who was working on that, they're called mechanical systems designers, that I wanted them to use extra large ducting and slow the fan speeds down. And the head designer, he kind of looked at me and says, "Really? Why do you want to do that?" And I said, "I want to save the energy." And he smiled because he understood. Not often he gets a customer who knows that that actually makes a big difference. And so we doubled the size of the air ducts, the diameter. Well, the airflow is as the square of the diameter. And so by doing that, we could move 4 times as much air for the same velocity going down that pipe, or we can slow the velocity down quite a bit to get the needed airflow to cool the building. So we reduced the airflow by 3/4. Well, by reducing the airflow 3/4, it's the square of that, which means that we reduced the fan energy consumption by almost 95%. Yes, doubling the diameter of the ventilation ducts saves 95% of the energy that it takes to provide airflow through the building to keep it at the proper temperature. So you can begin to see the powers of squares here. You really can take advantage of that. Conversely, most systems are designed with unnecessarily high speeds, and you're paying the price of the square. Doesn't your air conditioning use a lot of energy? Yeah, but it doesn't need to. And that's just how you save that energy is to slow it down. So slow air is quieter. In this particular factory, our product we're making is a powder, and we really don't want a lot of airflow blowing around because it can pick the product up and shift it and put it in places we don't want it. And the product is valuable. We really don't want to do that. And so we don't want to stir up the dust, is a way of looking at it. What's the downside? Well, it does take more space to put in the bigger ducts. We had plenty of space in this building for the large duct sizes, so that was not a problem. Potentially, there are other slight problems that you can get into um, with the larger duct sizes, but let your design team worry about that one. The big one is it can take a little bit longer to reach the desired temperatures, but frankly, most of us are more than enough patient for that extra minute or two for the temperature to stabilize. Down in the picture there, you see what this might look like. This is actually in a clean room. This is called an air wall. And you can see rather than a bunch of small ducts blowing air, they have a large wall of fans, because this was the standard size they came into. The red piping is the cooling water that cools the air. And then they have lots of fans moving the air. It's not a wind tunnel. The airflow is pretty slow and it's very energy efficient. And when you're trying to remove heat, the last thing you want to do is put a bunch of waste heat by running the airspeed too fast, because that extra energy gets turned into heat. We don't want to have that. I thought you might like to see, what does this look like for your home? So here's an example from a home. Most home forced air systems have the fan speed set to high. It's better, right? You cool quicker, you warm up faster, air gets mixed faster. However, if you slow the fan down, it'll be quieter and it saves quite a bit of energy. Remember the square rule. How do you do that? Well, you might want to have a technician do that for you. If you don't recognize the little picture there on the right of a schematic, you probably can't pick up the tech manual like I can and adjust the speed of the motor. It's actually, you're just plugging and unplugging wires back and forth. So you take the high speed wire out and you plug in a different wire that will run the fan at a slower speed. So it's already built into the unit to run at various speeds. In this particular unit, you just plug and unplug to get to a lower speed setting. You can insulate the floor. I have never seen a home with insulated floors. They are built, but that is pretty rare. It is 1/6 of the surface area of your building is not insulated. And so you can insulate the floor in your house and significantly keep it cooler in the summer and warmer in the winter. And I always found that to be a good job for teenagers. They're foolish enough to think it's cool to crawl underneath the house and stick fiberglass matting up into the joist of the floor. While they're down there, they should look for any air leaks. Unfortunately, there's a sloppiness in ducting that I don't understand. Everyone thinks that duct tape is magic. Well, actually, as the system operates, you pressurize it, depressurize it, pressurize it, depressurize it every time it turns on and off. And over time, duct tape will weaken and start to relax. And if all that's holding your ducting together is the tape, it'll fall apart and you start to get massive air leaks underneath or in your attic, wherever the ducting happens to be. They're supposed to have a screw that holds them together. The tape is just to keep the air inside. And so putting the screws in, actually, by the way, these are all things I did in my house. Well, I had the teenagers down there. I had them screw the ducts back together. Install a solar reflective roof. One of the houses in the picture on the right has a highly reflective roof. It's called a solar roof, and it keeps it a lot cooler. It's not particularly more expensive to put that roof in. If you're going to replace the roof, you might want to consider putting a solar roof in. If you're trying to figure out which one it is, it's the one that's the whitest. It's the upper center roof. That's a solar roof. And if you were to look at it in the infrared, it really stands out. This is just visible light here. And the obvious thing is lights is last. If you do have incandescent lights, especially anywhere that the light is usually on during the day, the payback to replace that with an LED light bulb is months. It's not years, it's months. It is very fast payback. If it's commonly used, like your kitchens, your dining room, your study, whatever it might be. So there's some examples that you can use. But today I want to talk and introduce this topic of the easiest, most cost-effective way to save energy, or any resource for that matter, is by changing people's behaviors. You probably all might remember a parent yelling at you as a child, turn the lights off a room when you leave. That's not a bad behavior. Of course, you know where lights are on my list of things to do. But this is a very powerful way, because habits are things that we always do. And if I can help people modify their habits to be more energy efficient, use fewer resources, you really can do this. Remember, I'm not spending any money. I'm just changing how we approach a problem. In general, energy saving behaviors are usually cheaper. It's not a bunch of extra work. I can give you an example of when that would not be true. We're going to turn everything off on back shift. Well, back shift time or weekend time, you have to pay overtime, and that can have a cost associated with it. And so if we actually analyze those situations, is it worth the time and money that it's going to take to pay somebody to do this to turn things off? And sometimes the answer is no. A lot of times we find automatic solutions, controls that do that for us, so we don't have to bring someone in to do it, to turn it off and then start it back up when we need it. Better behaviors increase worker satisfaction. I gave you the example of the young intern I had working on lighting. She talked to everybody. They were delighted that she was adjusting the light down in each one of their cubicles down to a level that was more comfortable for them. So here we are saving energy, and the worker satisfaction went up. And they really enjoyed when they came in before the lights came on. As they walked into the building, the light next to you would turn on and then turn off when you go by. So you had a pool of light following you around the building as you went to your desk or got a cup of coffee. They just thought that was fun. Better behaviors, sustainability wise, are usually safer. A lot of times, if you remember the story of the person cutting up the boxes, that was an unsafe behavior. When we realized it was also a wasteful behavior, we made it both safer and we eliminated the waste. And so you get those double benefits. They generally tend to come together. And here's kind of my thoughtful key. I would look for existing behaviors that we could slightly modify and make it part of the new behavior. And so this was something that I actually also not only used for sustainability, I was in charge of my company's COVID response. And so we would encourage people to, we're trying to get them to not touch all the silverware when they got a piece of silverware out of the plastic fork or knife dispenser or the paper cup dispenser. And we found that that is really difficult to do. But we did find that people like serving others, and so we could train one or two people to wear gloves and keep their hands clean and hand people what they needed. And that's a very positive thing. It's a positive behavior. We actually did that at my church. And they so much liked serving the food and serving the coffee that even though the COVID rules went away, the church continued doing that because it was a good time of fellowship, of serving each other. So that's an example of taking a good behavior, being kind to someone, and leveraging that. In that particular case was to keep people free from potential exposure to a disease. But you can also do that in the workplace or in your own home, modifying your behaviors that you already have in a way that also reduces waste in the environment. Well, I hope you've enjoyed this discussion today, and I look forward to giving you a case study next week so that you can really see what it is that I'm talking about changing behaviors. Hope you enjoy meeting with me again next week.